Entering a confined space that might have a hazardous atmosphere without making sure the air is safe is careless and could cost you your life. Hazardous atmospheric conditions cause 90% of all confined space fatalities. A confined space is any area that can be entered, has limited ways of getting in and out, and is not designed for continuous occupancy. Air doesn't move freely through most confined spaces, and with no air currents to flush the atmosphere, hazardous gases may collect inside the space. This makes testing the atmosphere a necessary step at confined space entry. Testing will warn you if the atmosphere is hazardous and identify the dangers so you'll be able to eliminate them. This program will help you understand atmospheric testing in confined spaces. You'll learn the three major atmospheric tests, the importance of calibration, and how to respond if testing proves the atmosphere unsafe. An untested space is a mystery, a dangerous one. If you do not solve this mystery, it could kill you. Let's narrow the unknown into what could await you in an untested confined space. You might find air that contains too little oxygen to support life. Breathing oxygen-deficient air causes loss of judgment, loss of coordination, fatigue, vomiting, unconsciousness, and ultimately, death. By the time you realize you are suffering from oxygen deficiency, your judgment is so impaired that you might not be able to save yourself. Then there is the chance the atmosphere itself will burst into flames. A high volume of oxygen or flammable contaminants is the most likely culprit here, and the smallest spark or heat source can ignite catastrophe. And then there are the poisons or toxins. These can poison and even kill you with one breath, or the damage may work slowly and not affect you for many years. Each of these conditions is serious and deadly, but preventable. Atmospheric testing solves the mystery of these dangers lurking within a confined space. Before anyone enters the space, for any reason, the atmosphere must be tested. The purpose of pre-entry testing is to warn you of atmospheric hazards before you or a coworker enters the confined space. Remember, the air must be tested before anyone enters the confined space for any reason. There are three main tests that will identify the atmospheric hazards of a confined space. The first is for oxygen content, the second test for flammability, and the third for toxicity. You always test the space for all possible hazards before entering. Never enter a space for any reason that has not been tested. Whether it is at the beginning of your shift, after lunch, or maybe you step out of the space to grab a tool to stretch your legs. Always retest that space before re-entering. To find out which tests are needed for a specific space, check the confined space entry permit. The permit will guide you through atmospheric testing. It tells you which tests are needed, the testing equipment and procedures to use, and the atmospheric conditions that are acceptable for safe entry. Perform all tests listed on the permit and enter the results on the permit form. Even the most sensitive and advanced devices need to be checked and calibrated before being used. There are two steps to good calibration. Before leaving for the space, use a known span gas to calibrate your instruments. Since you know the concentration of the span gas, you will know exactly how the instrument should respond. If it does not respond as planned, there's a problem with the sensor. As you head out to the space with the instrument, there's a chance it will be knocked and jostled. So perform a simple function check in the field before using. For an O2 sensor, simply breathing into it will reduce the oxygen level to 19.5%, if not lower. For a function check on combustible gas sensors, use a solvent magic marker. Holding the marker up to the sensor will give you a response. Although a butane lighter will definitely register, it is dangerous to introduce an open flame in an area with a questionable atmosphere. There is no way to perform a function test for toxicity sensors, so make sure you calibrate accurately and transport the instrument carefully. Function checks do not replace calibration. A function check only confirms that alarms are working and that sensors haven't been damaged since calibration. Before testing, be sure to check the battery and check sample hoses for obstructions or tightness. Be sure hoses and probes are long enough to sample the entire space. Know the time it takes to get a response after drawing a sample. Make sure you have calibrated properly and that the response and alarm set points are functioning. Initial tests of oxygen level, flammability, and toxicity must be performed from outside the space. Take samples through a pick hole or a slightly open cover on the side of the space to prevent wind or air pressure from blowing possible contaminants in your face. If ventilation is being used, turn the system off for pre-entry tests. After pre-entry testing, turn the system back on and retest the air. This will help determine the effectiveness of the ventilation system. Test all vertical levels of the space, top, middle, and bottom. Some hazardous gases, such as hydrogen sulfide, are heavier than air and will collect at the bottom of the space. Some, like methane, are lighter than air and will collect at the top. And others, like carbon monoxide, are about the same density as air and can be found in the middle level. These gases are very dangerous, and failure to check each level could be a fatal mistake. Test as much of the space's horizontal area as you can reach by remote probe from outside. Hazardous materials can collect in pockets, and you must identify these areas before anyone enters. If any test shows the air to be unsafe, alarms on the instrument will indicate the hazardous conditions which must be controlled before anyone goes into the space. This may involve additional cleaning or ventilation. Don't just assume that these measures have then eliminated the hazard. Always retest. It's oxygen in the atmosphere that keeps us alive. Normal fresh air is about 21% oxygen. The air in a confined space is considered hazardous if its oxygen content is less than 19.5% or more than 23.5%. Oxygen deficiency, an oxygen level of 19.5% or less, can be caused by bacterial consumption, a chemical reaction such as rusting and burning, or it may be caused by displacement, when another gas moves in and takes over space once occupied by oxygen. Air with more than 23.5% oxygen is oxygen-enriched. This is a severe fire hazard, since oxygen-enriched air can cause combustibles to burn violently. There are many different instruments for testing the air's oxygen content. These instruments can save your life, but you must use them correctly. Follow the manufacturer's instructions. Also, you must understand instrument limitations. Some devices are accurate only within specific temperature and humidity ranges. With others, certain chemicals in the air can cause inaccurate readings. Test slowly and carefully. Flammable gases can be odorless and invisible. But if the concentration of a flammable gas is high enough, even a minor source of heat or spark can cause the air to burst into flames. The air in a confined space may be considered hazardous if the concentration of a flammable gas is greater than 10% of the lower flammable limit, LFL, or if the concentration of airborne combustible dust meets or exceeds its LFL. The LFL is the amount of a flammable required for an explosion or ignition to occur in normal air. Conduct the flammability test after the oxygen test, since many combustible gas indicators won't work if the air is oxygen deficient. It's important to remember to test throughout the space, from top to bottom, covering as much horizontal space as possible. Small pockets of flammable gas can ignite, even if surrounded by non-flammable gas. These pockets of gas can be missed by testing instruments. So don't rely on the minimum accepted safe level. Try and work with levels above the minimum for a safety cushion. In many confined spaces, a toxic atmosphere may be present. Some toxins can cause severe health problems, even death. When you enter a confined space, your health, perhaps your life, depends on advance warning of any toxins that are present. Each toxic gas has permissible exposure limits, expressed in parts per million. These levels determine the allowable time-weighted average, the short-term exposure limit, and instrument ceiling level. Be sure the alarms in your instruments are set to go off at the appropriate level for the gases you expect to monitor. Even if the oxygen content measures between the allowable 19.5% to 23.5%, and the flammable vapor concentration is below 10% LFL, it is still possible for the air to contain a higher concentration of toxins. Check the entry permit to see exactly what atmospheric toxins could be present in the space and determine the PEL. There are several types of instruments for measuring toxicity. Many detect individual chemicals, such as carbon monoxide. Others can detect a number of toxins at the same time. Make sure your instrument will measure any toxic contaminant listed on the entry permit. If more than one toxin is named, you may need several devices to detect each one. Do not use a combustible gas indicator to measure for toxicity. Many combustible chemicals are health hazards at much lower concentrations than their lower flammability limits. A combustible gas indicator might not accurately measure the low levels at which these materials are toxic. An instrument designed to measure one specific gas measures gas concentrations more reliably than a general gas instrument. Pre-entry tests will determine whether or not the atmosphere in a confined space is safe before entry. This is essential, but not enough. Your health depends on making sure the air remains safe the entire time you're working inside the space. Work performed within the space often changes the atmospheric conditions. In order to ensure that the atmosphere remains safe, continuous atmospheric testing is needed. Immediately after you enter the space, repeat all three tests. Check the top, middle, and bottom levels, and cover any area you couldn't reach from outside the space during pre-entry testing. Be especially thorough in areas where contaminants might leak into the space or accumulate, such as around pipes and irregular surfaces. If you must go into an untested area, wear a supplied air respirator until tests are complete. Test with a direct reading instrument and a remote probe or detector tubes so that you can test each area before actually entering it. After entry, either periodic retesting or continuous monitoring is needed. The entry permit will tell you if continuous monitoring is required. If continuous monitoring is not necessary, the permit will state how often the air must be retested. Continuous monitoring maximizes safety if you will be doing work that can create hazardous conditions inside the space. This includes scraping, scaling, using solvents, and performing hot work, since any of these operations can cause changes in the atmosphere of the space. Position monitoring instruments so that they monitor the air that you are breathing while working in the confined space. Don't forget the space needs to be tested every time it is entered. If the space is vacant during your lunch break, don't just assume because it was safe before you went to lunch that it is still safe. It must be tested before you re-enter the space. It also needs to be retested if work will be continued by a new shift of workers. If the air in a confined space becomes unsafe during entry, your life may depend on responding quickly and correctly. Get out of the space if the alarm on a testing device goes off, or if tests show the atmosphere has become hazardous. Stop all hot work at once if there's any possibility the air has become flammable. Evacuate the space immediately if toxin concentrations elevate above alarm levels. After evacuation, identify and control the source of trouble. Then retest the atmosphere before re-entering the space. The air we breathe is essential to life. When we inhale, we expect the air to be free of harmful gases and will supply enough oxygen to keep us alive. Usually this is the case. In a confined space, however, the situation is different. Here there is a very real chance that the atmosphere is hazardous. Never assume that the air in a confined space is safe. Always perform every test listed on the entry permit before you enter. Use accurately calibrated instruments and follow the proper procedures. If the air is unsafe, do whatever is needed to control the danger before entering. Testing. Testing. This is your only way of making sure you can leave once you have entered a confined space.